Welcome students. So back to the session. So today we are going to discuss about electrostatics, IDJE problems mainly. So first we move to the problems. So consider a particle of mass m and charge minus q is projected horizontally, projected from the origin horizontally with a velocity v into a field of intensity E vector. Let us field is in the downward direction, the field of intensity, that is E vector, directed downwards. So from this option A, B, C and D, choose the wrong statement. Choose the wrong statement and neglect gravity. So this is very important. You want to neglect the gravity here. So here no gravity, so gravitational force is 0. So here the electric field is acting in the downward direction in that given diagram in the xy plane. So along the x direction, initial velocity of the particle will be there, that is Vx is alone there, mass is m, charge is minus q, and this is the y component. There is no initial velocity along y axis. Field is in the downward direction. So field always passes from positive to negative. So this is a negative charge, so charge gets deflected in the upward direction. So it is very clear. That is, in the y axis the charge gets deflected because of the downward electric field. Negative charge will be accelerated opposite to the direction of the electric field direction. So here they are asking the wrong options, wrong statements you want to choose, not the correct statements, and neglecting the gravity. So first we see that kinetic energy after displacement y is QEY. Kinetic energy of the particle after displacement y is QEY. That is, if the particle gets displaced to a certain distance, this is your displacement y. So at this point the charge q gets displaced up to a displacement y. So at this point they have given only the kinetic energy for the y-axis, but actually the kinetic energy will be the x-axis as well as y-axis. That is, the kinetic energy should be written, that is QEY, that is force into displacement along y direction. That is, in the upward direction the force, that is QE is the force, electric force acting, and displacement is y. This is for y direction, plus the x direction also we want to add. What is the x direction force? So initial velocity is, kinetic energy, initial velocity is v and mass is there. So we want to write the initial kinetic energy also, that is half mv square, vx square. That also we want to include. But here the kinetic energy after displacement y is only QEY. That is, only y component kinetic energy is written. So the first statement itself wrong for this. Next one, acceleration along horizontal direction is 0, vertical direction is QE by m. It's right. Because along they are asking, they neglect the gravity. So there is no gravity. So field is acting in the downward direction. So the acceleration will be ma is equal to QE. So a is equal to QE by m. This is obviously in the vertically upward direction, that is called ay. But in the horizontal direction, none other forces are acting. That is given there. So none other forces are acting in the horizontal direction. So ax is equal to 0, ay is equal to QE by m. So option B is right, option A is wrong. And equation of trajectory is, we know that y is equal to uyt. Uy is 0. Initial velocity is 0 along y direction. So uyt is 0 plus half 8 ayt square. Actually ay is QE by m. So QE by m t square. What is t square? In the next option they have given. Along horizontal displacement is x equal to ut plus half at square. So a is 0 along x direction. So x is equal to vt because initial velocity is v. Y equal to half ayt square. So from this we can determine t is equal to x by v. So that we can substitute it here. So QE by m into t square, that is ay, this is half ayt square. So ay is QE by m, t square is x square by v square. So option B, option C and option D, all the three are right. But they are asking only the wrong statements. So the option A is the wrong statement out of the 4 options. So option A is the wrong statement because they have given only the kinetic energy along the y-axis. They want to provide the kinetic energy for the displacement of y for the x-axis also. Because on reaching a displacement y, it possesses both kinetic energy along y direction as well as x direction. So I think you understood this problem. So next problem, a particle of charge minus q and mass m moves in a circular path of radius r around an infinitely long line charge of charge density plus lambda. So the charge density of this infinitely long line charge is plus lambda. We know that lambda is q by L. so no need to take that into account. And you want to find the time period of the moving negative charge in this circular track, okay, around the infinite long line charge. This is not a finite charge, this is an infinite line charge. First thing we want to concentrate. So we studied a concept in atoms lesson, that is any particle which is moving around a nucleus, an electron is moving around a nucleus, so the kinetic energy of the electron will be half the potential energy. That idea we can use it here. That is, kinetic energy of the revolving charge will be the half the potential energy provided by the line charge. Similarly, nucleus is providing some potential energy, that half the potential energy value will be the kinetic energy of the moving electron. The same concept we can apply here, or centripetal force application also we can use. So first we try this. We know the kinetic energy formula mv square by 2, that will be equal to, so here the potential energy. So first we know the potential energy, we can write it as force into displacement by 2, because here the force is naturally electrical force. So the line charge will be lambda. So we know that the electric field due to a line charge is lambda by 2 pi epsilon naught r. Okay, so this is the field. So QE is the force, so which will be lambda q by 2 pi epsilon naught r is the force experienced by this negative charge. The magnitude of the force experienced by this negative charge is QE, that is lambda by 2 pi epsilon naught r into Q. So we want to find the, that is, this is the potential energy, that is half the potential energy will be the kinetic energy. So substitute in this, so we are getting mv square by 2, that will be equal to, so fd by 2 will be cancelled, so we can write it as mv square. So f into d, displacement, what is the displacement? The distance between the center and the rotating charge will be r. So I can write that as lambda q by 2 pi epsilon naught r into r. So r will be cancelled. So finally we are getting, so we want to find the time period of this charge. So how will you do the time period? We know that time taken is equal to distance by speed. So here the distance is 2 pi r, and speed we can consider it as v. So now v is equal to, substitute in that, so 2 pi r divided by v. So what is v? So here we have v square, so we can consider that v. So I can write that 1 by v as, so what is 1 by v? So 1 by v is equal to, so it will be lambda 2 pi. I can consider this 2 pi epsilon naught. Actually we know that 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught is k. So we can multiply and divide it by 2. So I can write it as 1 by 4 pi epsilon naught. So I can write it as 2k lambda q by m. This is v square. So v square is 2k lambda q divided by m. So I can write 1 by v is equal to, it is root of m by 2k lambda q. So finally I can write it as m by 2k lambda q. So this is the time taken, time period of the rotating negative charge. So 2 pi r into root of, 2 pi r into root of m divided by 2k lambda q. Actually this k is 1 by 4 pi epsilon naught, that we have mentioned here, and we have multiplied and divided by 2, so we are getting 2k lambda. Okay, 1 by 4 pi epsilon naught is k, that is 1 by 4 pi epsilon naught is k, so 2k lambda q that we have written. So this is the time period. So in this way we can find. The other way is, we can use the centripetal force idea, mv square by r, that we can equate with the potential energy. Same idea. So if you substitute, you will get the same answer for the time period. So you know that same potential energy, force into displacement. The same idea you will use it here. So you are getting the answer. That is here, it's a force. Only force we can use. So the force is, no need to, because this is force, this is energy. So force, so we can write it as mv square by r. So the force is, here we have written, this is the electric force, which is lambda q by 2 pi epsilon naught r. On rewriting, r will be cancelled. So the same thing you are getting. So this is the other way of finding the time period. So this is the way to find the time period of a negative charge which is moving around a infinite line charge. So I think this problem is also quite easy for your understanding for the IIT Advanced and Mains. So in the next question, so we have two identical positive charges are placed at x is equal to minus a and plus a, that is x, that is along the x axis. We have two charges, one is kept at minus a plus a, like that charges are kept, the correct variation of the potential graph. They have given both are positive charges, identical plus q, that is plus q plus q plus q plus q. So which graph is perfect for the potential versus x-axis, that is potential, variation of potential along x-axis. First we want to consider it is both are positive charges, and you have know how to depict the electric field lines for two positive charges which are kept very close to each other and they are identical, that is plus q or plus 2q plus 2q, like that. So we know the depiction of field lines around that, and we know that, so which is very essential, it is kept from the origin at equidistant. First thing we want to know, this is negative charge and this is a positive charge. So when you move away from a positive charge, the potential keeps on decreasing because V is equal to kq by r, that is 1 by 4 pi epsilon naught r, that is on the one side, and at infinity it will be moving towards 0. Similarly on this side also charge V is equal to kq by r, so that is also correct, it moves towards infinity. But between the two things, both are positive, sorry, so kq by r, but here initially near this we have a field that is very near to this, the distance is very very small, so the potential will be infinity, and this potential will be a decreasing one. Infinity plus this finite will be again infinity, so it will be from infinity. And at the center means 0, they are at equal distance, A and A, so the potential will be kq by A, so which will be 2 kq by A, it will be a finite value, it won't be 0. So in this graph, so this is reversed, it is moving towards 0, this is not moving towards infinity at very nearby distance. So here it is infinity and here it has a finite value, it is not moving to 0. So finite value and again moving to this side infinity, because this distance is very near to this charge. So infinite potential, very near to the charge, potential will be infinity. Far away from the charge, potential keeps on reducing, but it is not moving to 0 because of this charge potential also acting on this. So it has a finite value 2kq by A. It is 2q by 4 pi epsilon naught A, because this will produce kq by A, this is producing kq by A, both are positive. So no zero potential. So out of this 4 graphs, so this won't be fitting to this because potential won't be negative, because both are positive charge. Here also this is also not fitted, this is also not fitted because potential becomes 0 very near to both the charges. So option C is right. So option C fits to this characteristics of the two charges are positive and they are separated by equal distance from the origin, and in the left side and right side region, that is away from both the charges, potential decreases by 1 by r, that is at infinity only it becomes 0, but in between the two charges it will be in a U shaped, that is very near to the charge it will be infinity, potential will be infinity, and at equidistant point at the origin it has a finite value 2 kq by A, it won't be 0. So option C is right for this question number 3. So I think this session will be a nice session for the students to understand good type of problems from the lesson electrostatics. So I think in the future discussions you can understand more problems from this electrostatics lesson and from the volume 2 of our class 12 NCERT textbook based questions, that is for the IIT mains and advanced. So thank you. So please subscribe our Guru Shiksha Physics Karpam channel.